Welcome class 10. Today's topic is levers. So a lever is a rigid, straight or bent bar which is capable of turning about a fixed axis. So in a lever we have fulcrum, which is a pivot point around which a lever turns. Principle of a lever. Suppose if we have a lever which has a fulcrum, and towards one end it has a load, and in the other end effort is applied. So the distance from the effort point up to the fulcrum is called the effort arm, and from the fulcrum the distance up to the load point is called the load arm. Now we can see over here, now since this load is able to turn the lever in this clockwise direction, so it will produce a moment of force. So here the moment of force, that is for the moment of force for load, will be equal to the force load into the moment arm, that is the load arm. So that is the distance from fulcrum to the load point. So load into load arm, that will give the clockwise moment is the moment of force for load. And similarly, moment of force for effort, since effort will tend to turn the lever in the anti-clockwise direction, this direction, since its force is downwards. So effort and multiplied with the effort arm will give the moment of force which will be in the anti-clockwise direction. So as per the principle of lever, the moment of force for load and the moment of force for effort, if they are equal, then we say that is the principle of lever. So clockwise moment of load about the fulcrum, so this is the clockwise moment produced by the load, that will be equal to the anti-clockwise moment produced by the effort about the fulcrum. If they are equal, then that is the principle of lever. Now since clockwise moment of load about the fulcrum is equal to anti-clockwise moment of effort about the fulcrum, so we can replace the clockwise moment of load by load into load arm, and similarly anti-clockwise moment of effort as effort into effort arm. Now load into load arm, I am writing it as L into load arm and E into effort arm. Now if we bring this load, if we bring this effort down here in the left hand side, then it will go to the denominator. So it will be L by E, which is equal to, and this load arm comes towards the right hand side, goes to the denominator. So L by E is equal to effort arm by load arm. Now we know that L by E is represented as mechanical advantage. So we can write mechanical advantage is equal to effort arm by load arm. So mechanical advantage MA, which is equal to effort arm by load arm, is also called as the law of levers. So this means that mechanical advantage of a lever is equal to the ratio of effort arm to its load arm. So this is the statement that we get from this expression. Now from this expression, mechanical advantage which is equal to effort arm by load arm, if we see clearly here, effort arm, if it is greater than load arm, that is the numerator becomes greater than the denominator, then the total value of this fraction becomes greater than 1. So the mechanical advantage becomes greater than 1 if effort arm is greater than load arm. So if effort arm is greater than load arm, then we say the mechanical advantage is greater than 1. Similarly, if the effort arm is less than load arm, that is the fraction will be less than 1. So the mechanical advantage will become less than 1 if the effort arm is less than load arm. And similarly, if both the values, the numerator and denominators are equal, if effort arm becomes equal to load arm, then the fraction becomes equal to 1. So the mechanical advantage becomes equal to 1. So when effort arm equals load arm, then the mechanical advantage is equal to 1.